We could use ADT list to implement our queue. List-based queue implementation is much simpler. The front is the position 1 of the list. Back is the item at the end of the list. We could use the list remove method, get method, add method to implement our enqueue, dequeue, pick methods. Inside the list queue class, we only need one pointer, the list. Inside the constructor, we just create the list. But here we use reference-based list. You can see its empty method of the queue can be implemented with a list.isEmpty. Because the list class has remove all method, we can use list.removeAll to implement our dequeue. For enqueue method, we just simply add the new item to the list size +1 position. dequeue will simply remove the item in the position 1 of the list. Of course, we need to check if the list is empty or not. If it is empty, we have to throw exception that indicates we cannot dequeue anymore. Otherwise, we just define a queueFriend variable to point to the first item in the list, and then call remove method of the list class by removing the first item in the list, and then return the item in the position 1. Pick method of the queue class is similar to the dequeue method. Here we just simply return the first item in the list by using get position 1 item. Of course, if queue is empty, we cannot pick, we just throw exception. So far we have learned 3 ways to implement our queue: reference-based, array-based, ADT list-based. Reference-based is more flexible but no size restriction. Array-based does not have pointer manipulation. However, there is limited size of array. When array is 4, we cannot enqueue anymore. For ADT list-based, it is simpler to write. However, inside the list, that is linked list. So this ADT list-based queue is not as efficient as using linked list directly.